Alright, so this is question number 22 from the January 2023 statewide test. And it says a cone of maximal volume is inscribed in a cylinder with height 4 and a radius of 2. So I should probably draw this out, but I don't feel like it yet. So I'm going to keep reading. A cylinder is then inscribed in the right cone. Find the ratio of the lateral surface area of the larger cylinder to the maximal lateral surface area of the inscribed cylinder. Okay, so now I'm going to draw it out. We have a right cone, just a cone of maximal volume that's inscribed in this beautiful, expertly drawn cylinder. And it looks like this. That's the cone. And so if the cone is going to have the maximal volume within that cylinder, well, then the base of the cone is going to be the same size as the base of the cylinder. So the radius is going to be 2 inches, and the height is going to be 4 inches. And so now what we're going to try to do is there's another cylinder inscribed in this cone, and we're supposed to find the ratio of the lateral surface area of the larger cylinder, so that's just the surface area minus the bases, so the ratio of that to the maximal lateral surface area of the inscribed cylinder. So let's start by trying to find the lateral surface area of the tiny cylinder, and so we're going to do that by taking that cone and slicing it in half in order to find the cross section. And so here's our cone sliced in half. Here's our cylinder sliced in half, and it looks like a rectangle, but in case you hadn't heard me say it enough, that's because it's sliced in half. And we're trying to maximize the lateral surface area of that cylinder, so that's only going to happen when we're maximizing diameter. So we want this length right here to be as large as it possibly can be. So you know what that calls for? Optimization. Don't we all love optimization? That's a joke. No one loves optimization, and if you do, you're weird. But essentially, what we can do is we can use similar triangles. This triangle right here is similar to this triangle right here because this is a rectangle, or at least it's supposed to be a rectangle, to which if I were to cut it down the middle, it would be parallel to this side, making these two corresponding angles, which are congruent, and then making these two the same angle because it's by reflexive property, and then this is also just 90-degree angle, 90-degree angle. So those two are similar triangles, needless to say. So let's call the radius of this cylinder r, and since this entire thing is 2, that makes this section 2 minus r. And like I said, since this triangle is similar to this triangle, and the height of this triangle is 4, so twice the size of the radius, which is half the base. That means that this length right here, the height of this triangle, is also going to be twice the size of the base, which is 4 minus 2r, so that's 2 times 2 minus r. And so we're trying to optimize, right, maximize the lateral surface area of that cylinder. And so if you were to look at this cylinder, the lateral surface area, so the surface area of that base is, if we were to just like cut it on one side and unroll it, it would be a rectangle with a length of the circumference, so and then a width of the height. So the area, the lateral surface area of a cylinder is going to be the length, which is 2 pi r, which is the circumference, times the height. And so we know the height in terms of the radius, and then we also just know the radius in terms of the radius, because it's the radius. And so we can put our equation for the lateral surface area in terms of r. So we have 2 pi r times the height, which is 4 minus 2r. And so I want to factor a 2 out of that second factor, so it's easier to differentiate. So we get that the area is 4 pi times r times 2 minus r, which is equal to 4 pi times 2r minus r squared. Now we're going to take the derivative of this whole thing with respect to r, and wherever this equals 0 is where the function is maximized. So that's the r value that we want. So the derivative of this with respect to r is equal to 4 pi times the derivative of 2r minus r squared, which by power rule is 2 minus 2r. And so where this equals 0 is where 2 minus 2r equals 0, which is when r equals 1. So a radius of 1 is our radius that gives us the maximum lateral surface area of this cone. So what is that lateral surface area? Well, let's just plug it in. Remember, we know that our height is 2 times our radius, so the lateral surface area is going to be 2 pi times our radius, which is 1, times the height, which is 2 times the radius, remember, so that's 2, and so it's equal to 4 pi as the lateral surface area of the small cylinder. Now, as for the big cylinder, the lateral surface area is going to be the same thing, 2 pi r times the height. In this case, we specifically know the radius and the height, so 2 pi times the radius, which is 2, times the height, which is 4, gives us an area of 16 pi. So this is the area of the big cylinder, and then this is the area of the small cylinder. So the ratio is going to be 16 pi to 4 pi, which simplified becomes 4 to 1. So that right there, answer choice B should be the answer.